In this logistic regression example, we are considering Siemens stores. They operate a national chain of women's apparel. Now they have printed 5,000 copies of an expensive 4-color sales catalog, and within the catalog they have included a $50 discount on purchases of over 200 or more coupon. Now, since the catalogs are expensive, Siemens wants to send the catalog out to customers who are likely to buy products and use the coupon rather than those who may not buy. The management thought there are a couple of variables that would be related to buying decision by the customers. And one is whether the customer holds the store credit card, the Siemens credit card. The second variable is the annual spending by the customers at Siemens stores. These are the two variables they want to consider in the analysis to determine whether the customer is a good potential or not. So they took a random sample of 100 customers, 50 of them with the credit card and 50 of them without the store credit card. So they have 100 customers selected. They sent out the catalogs to these 100 customers, and then at the end of the test period they noted whether the customer used the coupon or not. So now we have 3 columns of data: the annual purchases of the customers from Siemens, whether the customer holds Siemens card or not, and during the test period whether they used the coupon or not. So now let's go to Excel. Here is the data: 100 customers and annual spending, whether they hold the card or not, whether they use the coupon or not. So this is our logistic regression model. So y is 0 if coupon was not used, 1 if coupon was used. So then we have the L. Now this has only 2 variables, beta sub 1, x sub 1, beta sub 2, x sub 2. And then the expected value of y is given by this, as we have already seen in the previous video. So now what is y? Y is whether the customer will use the coupon or not. One if customer will use the coupon, 0 otherwise. Now x sub 1 is the annual spending of the customer, and that is in thousands. X sub 2 is whether the customer holds Siemens card, and we will use 1 if the customer owns the card, 0 does not own the card. Now our first step is to estimate L, the estimates for these beta coefficients, and I've already run this data through SAS, and here is the SAS output. There are 3 sections to this SAS output. The second table gives us the estimates. So these are the estimates: the intercept, credit card, and spending. The first table gives us the significance test p-values, and there are 3 different ways in which we can test the overall significance. So these are the p-values, and then the individual test p-values are here, and then we have the odds ratio in the third table. So let's get the estimates for the beta coefficients from the SAS output. Intercept b sub 0 is right there, and we can copy that formula down below to get b sub 1 and b sub 2. b sub 1 stands for annual spending, b sub 2 is for whether you want the credit card or not, whether the customer wants the credit card or not. So now the estimated L value can be constructed with these coefficients. So minus 2.1464 plus 0.3416 except 1 plus 1.0987 except 2. Then we can put the L value in this equation to find y hat, which is then the probability that y will be equal to 1. In other words, the probability that the customer will use the coupon. We can find a point estimate for that y hat. So how would we do that? So we have a question here. Consider a customer who spends $2,000 annually. So that $2,000, since x sub 1 is in thousands, value for x sub 1 will be 2, and does have a credit card. So x sub 2 will be equal to 1. Then we can find L by using these coefficients b sub 0 plus b sub 1 times x sub 1 plus b sub 2 times x sub 2. Then e to the power of L is exp L, and then y hat is that formula. So e to the power of L divided by 1 plus e to the power of L. So 0.41. So a customer who spent $2,000 last year and does have a credit card has a probability of 0.41 that they will use the coupon.